Hello everyone, my name's Bridgette and similar to Lucy, I'm currently on Wurundjeri Woiwurrung country and would like to acknowledge the Wurundjeri people as the traditional owners and thank them for having me and thank them for their ongoing care for the land. So my presentation today is about the importance of the brief and the impact of structures on carbon reduction. So buildings and construction, just to set the scene, currently account for around 40% of the world's energy-related carbon emissions, which is a pretty staggering amount. And when we talk about the substructure and the superstructure specifically, that's referring to foundations and the structure above ground. Typically more than 60% of a building's embodied carbon is from the structure itself. So when I say more than 60%, that depends a bit on which building type. So this is UK data, but is generally applicable in Australia as well. So you can see that for a commercial office, for example, 65% of the building's embodied carbon comes from the structure. And you can see on the right-hand side that the remaining 35% comes from things such as the façade, MEP, which is all the services, and the internal finishes. So a few numbers for you here. If the structure is 65% of a building's embodied carbon, then if we can reduce the structure's embodied carbon by 60%, then that means we can obtain nearly a 40% reduction in the building's overall embodied carbon, which would be pretty great to achieve. So this is a similar graph to the one Lucy shared before. Mine's a bit less pretty, but it indicates that our capacity to reduce embodied carbon is highest at the concept design phase. And as Daryl said, it's really important to get in early. So if we're aiming for a 60% reduction in our structure's embodied carbon, I'll be honest, that's quite a lot. So we really need to plan for that from day one. And if we don't, we're going to really limit our capacity to reduce the embodied carbon. So here we can see the timeline of a project, and Daryl was talking more to the supply chain segment. I'm going to focus on the brief. At the brief stage, we make key decisions that have a big impact on the embodied carbon. And the first thing we need to do is decide if we can do nothing, as discussed by Lucy with the upside down pyramid diagram. And if building nothing isn't an option, then the next thing we look at is building less. So in order to build less, I'm going to share some more numbers, but stay with me, hopefully it's not too many. So first of all, if we look at floor loading, basically the Australian code requires that we allow for a certain amount of loading in different environments. So this slide is talking about live loading, which refers to non-permanent loading. So that's things like people and furniture. So in an office, for example, it's typically 3 kPa, and you can see what that looks like in terms of people. Keep in mind that in reality, this would be some people and some furniture. And the requirements go up to 5 kPa for more heavily loaded areas. It's worth noting that the client will sometimes request that we design for live loads higher than the code requires. And this can be for reasons such as including future flexibility of the space in the future. But this does unfortunately have quite an impact on the embodied carbon of the structure. So what kind of impact? Well, these are some numbers based on an example calculation done at Arup. So if we're looking at a 6-story post-tension concrete building, for example, with a 5 kPa live load as the base case, by reducing that to 4 kPa, we already achieve an 11% reduction in the upfront carbon. So that's stage A1 to A5 that Lucy mentioned in her presentation. And if we can reduce that to 3 kPa, then compared to the base case, we've got a 19% reduction. So yeah, pretty impactful and a pretty simple thing that we can do at the brief stage. The second thing is grid spacing. So when I refer to grid spacing, I'm talking about the spacing between the columns in each direction on a floor plan. And this has a great impact because strength and deflection are really very reliant on the length of the span. And here I've got an example of deflection. It not only increases with respect to L, but with respect to L to the power of 4. So you can imagine that as that length increases, the deflection increases a lot, and strength is similarly proportionate to length squared. So, you know, we have slab elements standing between beams and then beams standing between columns. So as you can imagine, this impact accumulates throughout the floor plate. So if we look at the potential reductions from the example from before, if we start with a 9x9 scenario, reducing that to a 7.5 meter squared grid gives us already a 23% reduction in the upfront carbon of the superstructure. And if we reduce this to 6 meters squared, it's a 38% reduction. So it's a pretty substantial amount. And it's also not necessarily so intuitive because, as you can see, reducing that spacing means we actually have more columns, but it just goes to show the impact of the length on the size of our slabs and beams, because that's the amount of material we save by reducing the grid spacing. And the third thing that's really influential that we can discuss at the project brief stage is materials. So wherever possible, we should use materials that sequester carbon, which would be timber. And where we can't specify timber, we should be specifying materials with lower embodied carbon. So you can see these embodied carbon amounts for different floor plate typologies are from a previous project at Arup. It was a mid-rise university building, and timber, not very surprisingly, performs the best. So the third dot point is just pointing out that actually if timber isn't able to be applied to the whole project, it's actually, you can still apply it to a lesser degree with use of hybrid structures. So in summary, we really need to be having these discussions from day one, not only with the client, but also the architect. And we should be asking, first of all, do we need to build this or demolish this? Can we do nothing? It's a very relevant question, particularly for existing buildings. Next, we want to look at how we can optimize the structural efficiency with respect to grid dimensions and floor loads. And thirdly, we want to be trying to use as sustainable materials as possible. So the next segment of my presentation is looking at a tool that Arup has developed for early stage design. It is, of course, one of many tools being developed both within Arup and throughout the industry to help us design more sustainably. So it's called the Arup's Inform tool. It's a parametric design tool, and it's developed by the Arup team in Amsterdam. As Daryl mentioned, parametric modeling is a great method for material usage optimization. And in the Inform tool, we're also able to consider other KPIs to help us consider thousands of design options and quantify which best suits the project brief. So the tool looks at the KPIs that you provide it with. So these might be things such as the floor area of the structure, the embodied carbon, the amount of daylight that the building receives. And then you also give the tool the parameters it's allowed to vary. For example, floor area, shape and orientation of the building, number of stories, as you can see on the right, even the number of buildings and massing options. And it runs through these thousands of design options and quantifies the results. So the way we view the results is in the parameter space. So when you have thousands of results, it's not that easy to work out which one you want. So this helps us filter through those thousands of options using the KPI filters. So you can select which KPIs are most important to you and which ranges of values you're happy to consider. And then you can also select your favorites, and then we can go in and compare them based on their KPIs, and visually you can see what each option looks like. So now that I've given you a brief overview of the tool, I'll just show you an example of how this tool was used on a project. So as I mentioned, this tool was developed by the team in Amsterdam. So they used it on this project. It was a mixed use development with 2-story apartments, and the intermediate floors were done in CLT. So it's an example of a hybrid structure, like I mentioned earlier. So here we can see what the project achieved with the help of the Inform tool. In terms of sustainability, it optimized the location of the PV panels so that it had low energy usage, that's operational energy. And it also had a lower embodied carbon, primarily due to using the hybrid of timber and concrete. So here we can see the thousands of options that the tool ran through, varying things such as orientation and shape, and measuring how that impacts against the KPIs. And this slide summarizes the performance of the building. So you can see that there was a 51% reduction in the environmental impact of the building. This is including embodied carbon and also 75-year operational carbon. And that's compared to a reference case. And in the second from the top left, that's a visual of the CLT and concrete hybrid floor typology. So that's it from me. In summary, it's so important that we have these conversations on day one of a project about design decisions that will inevitably have large implications on the structure's embodied carbon. And we should definitely make use of tools to help us with these design decisions, because this way we can optimize with respect to KPIs, and we can do this quickly and easily on all of our projects. So that's it from me, and yeah, happy to answer questions.
Thanks, Bridgette. Impressive parametric work. I love it when you see consultants really starting to make the most of flexible technology tools that could be built and to purpose these days. Do you find clients, break the process here a bit and ask you this question now. Do you find clients generally receptive to that? And the vexed question of, do you think it's an extra cost to the service and the client should pay for it? It's just an integral part of what you do now.
Yeah, that's a great question. This tool, for example, is sold to the client, and the parameter space that I showed you, where you get to view all the results, the client has access to that, so they can go home and have a look through that themselves.
Or playing with the KPIs.
Yeah.
Good.
Yeah. Great. So in terms of my experience on projects, the things we offer like all the time is quick comparisons, like those calculations I was showing with 5 KPA versus 4 versus 3. We can run a quick calc and communicate that to the client. Yeah. And Arup also offers some internal funding for developing tools, and then we can use those on projects. But essentially the answer is, as much as possible, we try and do it just as part of our daily jobs. But when we really invest a lot in a fancy tool like the Inform tool, then it is a selling point to clients. Yeah,
that's an important point. Both you and Lucy touched on the build nothing option, and there's been an interesting thing going along in the chat. I mean, it's one of the challenges of these kinds of things, keeping track of what people are saying, thinking about what that means, and then keeping track of the chat. I mean, it's almost impossible to do everything. But it was an interesting exchange just now about nobody ever won an award for not building anything. So we'll, I'm aware that there's a lot going on in the UK and London in particular. Boroughs like Camden are sort of now saying you can't demolish unless you can prove the case that the existing building can be reused. And there's an interesting public inquiry with regard to the Marks and Spencer building in Oxford Street now on that. And so there's a real pendulum moving towards don't demolish, isn't there? You want to sort of elaborate on that a bit?
Yeah, you might have missed my response to that comment. We actually did give an award last year to somebody who didn't build anything, which we were quite pleased about at our structural awards, which was a team of engineers who managed to justify the reuse of, I think, 500 overhead gantries on a rail line, which were due to be taken down and replaced with bigger, stronger, newer gantries. And they did some, good analysis. And I think they proved in the end that about 10 or 20 of them needed strengthening. Most of them could just be left alone. And I think 3 or 4 were replaced, and they had a really happy clients, as you can imagine, at the end of all of that. Yeah, I mean, things are moving towards reuse here. You speak to any commercial developer or architect and funder, and they tell you that the amount of reuse in the last few years has just gone through the roof. I spoke to an architect last week who said that probably about 80-90% of their work now that they're currently working on in the office is all refurbishment jobs.
Yeah.
Everything's going that way. The M&S project, the M&S case is really interesting. I mean, this is a public inquiry that's now happening because Marks and Spencer put in planning application to demolish their flagship store on Oxford Street, which is sort of central London shopping street, and replace it with something that's bigger and has more levels of basements. And there was a carbon justification put in there behind it. And basically what happened is a bunch of leading LCA practitioners got together and decided that they thought that some big options had been missed and sort of flagged this to the local council. And this has gone up the food chain, and members of government were getting involved at one point, and now it's gone to public inquiry. So it's a really big topic right here in the UK at the moment, and it's really, really sorely needed. As a bit of a quick plug on the topic, by the way, we're releasing a guide at the end of this year on circular economy and reuse for designers. So it's written for structural engineers, but it's full of practical stuff that's equally applicable to architects. So I'd recommend checking it out if you've not sort of gone into that area before.